All right, here we're going to start on some examples that involve negative exponents. I've written an example here. I'll give you a second to write that out. The numerator is 7x cubed y to the negative fourth. And this is the first time we're seeing these negative exponents, so we got to figure out what to do with that. And my denominator is 21x cubed y cubed. What makes this problem different than what we've been doing is this negative exponent. I think I've said this a few times and I'm going to continue saying it. Firstly, we know it's not simplified, but before I make it simplified, I do want everyone to write this out in this expanded form, because we're going to start seeing problems where things get more and more difficult. And if we write it out showing our work the first time, or these easier problems, it gets it's more useful when we get to really hard problems. So if I see a constant, write that constant. If I see x cubed, well, that's going to be x times x times x. Y to the negative fourth. Now, if we look up here, just like how we had x to the negative 2, I took those two x's. I knew that it was to the second power, so there was going to be two x's. The negative just tells you that you switch between the numerator and the denominator. So right now, because it's y to the negative fourth, I got to put a denominator. I didn't really originally have one. I'm going to put those 4 y's down below. And what I had done originally was I used a marker to indicate those negatives, that negative 4, and I'm just going to do that for our case, just so you can see exactly where did those negatives go, what happened to it. All right, then I come down to the denominator. That 21 is in the denominator. Does it have a negative exponent? No, so it stays in the denominator. Does this x cubed have a negative exponent? No, it stays. And does this y cubed have a negative exponent? No, it stays. So we can start crossing things out. We can start seeing if anything eliminates. Let's look at the constants. So I have a 7 and 21. Is there a number that goes into both 7 and 21? There is. 7 does. 7 goes into 7 once. 7 goes into 21 3 times. So all my constants are simplified there. Is there anything else? And in this case, there is, because when I have a division symbol, or I have a numerator and a denominator, and I have one x on top, I can cross it off with one x on the bottom. Is there anything else that cancels out? Yep, because x divided by x turns into a 1, and that crosses out. X divided by x turns into a 1. Is there anything else? I think we're good. So let's look at our new numerator. At our new numerator, we have 1, and everything else crossed out, so that ends up being a 1. We do have to write it when it's in the numerator too. Constants goes first. We always put that number out in front. No x's. Awesome, those crossed out. And I have 7 y's, y to the 7th. And that is my simplified version of the original exponential expression that had negative exponents. Let's look at another example together. There is no no denominator currently. You will soon realize that we probably need one. There is a lot going on with this, so let's look and see how we can really dissect this and figure this out. Firstly, there is an exponent of 2. It almost looked like a z. An exponent of 2. That is just for what's inside of the parentheses. This 4 is all by itself. I might actually write this down below to give us some more room. So that 4 is just a 4. Like it's not going to get multiplied more and more. It's not going to be squared or anything. That 4 stays there. Then I'm going to take all of this and write it out twice. Write it out twice like that. But this negative exponent is causing an issue. What am I going to do? Normally I'd take those 5 x's and I'd put them in the denominator. And in this case, you just got to make a denominator, even though there wasn't one to begin with. That's okay. There was originally a denominator of 1. It was kind of hidden, but we're going to make our own. Then I have 2 y's. That stays in the numerator because it's a positive exponent and it stays there. And that z stays. Am I done yet? Nope. Everything in that parentheses needs to be written again now. So there's another x to the negative 5th. There's another y squared. And there's another z to the 1st power. And then I start looking and I start deciding, is this simplified? Like, what else can I do? There's only one constant, and I know my constant is simplified, so I'm good there. In fact, let me get that all started and ready. Do I have any x's on the top and the bottom that cancel out? No. Is there any y's that cross out? No. I actually think that there's nothing to simplify. We just took this, rewrote it, so that when we reread it in a more simplified version, we have everything all set up together. And I know it's simplified because there is no constants that are like can cross out or be simplified. There's no duplicate x or y, z's, variables. There's no there's no zero exponents. There's no negative exponents. That is enough examples for you if you would like to tune out at this point and start an assignment. But I do have a third example if you'd like to stick around and do one more problem with us. In the numerator, 4v to the third y to the fourth. In the denominator, 2v y to the negative third. So just like yesterday, I could have shown you this exact same problem, but this negative exponent is what's causing the problem, or not a problem, it's just that new thing that we're going to work on today, something that is new for us. Everything stays exactly the same unless there's a negative exponent. So if there is a 4 in the top, you keep the 4, a constant doesn't get changed around. V to the third power is 3v's. Y to the fourth is 4y's. There was no negative, so I didn't have to worry about moving something to the denominator. I left it exactly as it was. In the denominator now, there was a 2. When you see a constant, you just write it out. This v has a little exponent of 1. If you wanted to write that in, you can, but that exponent of 1 means that there's just one v. And lastly, this negative 3 exponent is our challenge for today. Where do those 3 y's go? And they actually go up in the numerator. And for the sake of our notes, I'm going to highlight those just to mark them that that's really what's being moved around. And then I take a second to say, hey, I bet there's something that I can simplify here. And in this case, there is. There are constants, a 4 and a 2. Can I simplify that? Absolutely. 2 goes into 2. I'm going to use a different color. 2 goes into 2 once. 2 goes into 4 twice. Are there any other variables that cancel out? Yes, there's 1v and 1v. Those turn into 1s. There's nothing else that crosses out. I have no zero exponents. I have no negative exponents. So I'm able to write my answer. In my numerator, my constant is a 2. I only have 2 v's, so v squared, and 1, 2, 3, 4, 5, 6, 7 y's. And in the denominator, it's 1. I think I've said this multiple times recently. You do not have to put that 1 if you do not want. Both are appropriate.